Here's how to set up a Cleaver Brooks integral burner. So the integral burner is a very common burner that is on the Cleaver Brooks dryback fire tube boilers. This Boilearn Burner Linkage Trainer has the same qualities of the integral burner linkage setup. So let's get started. So first we have our mod motor, and our mod motor, depending on the size of the boiler, will either be below the jack shaft or above the jack shaft. Doesn't matter from a set point. One is just moving the linkage up, and then the other would just be moving the linkage down. In this case, we have it below, which you're going to find for bigger boilers. On smaller boilers, it may be above. So we have a adapter. So the Honeywell Module 4 motor has a 3/8 inch square. So the adapter goes square to round. So we're going to use an adapter. And then we also have an arm. So that arm gets put on the adapter, and Cleaver Brooks want this arm to be 45 degrees below horizontal. Doesn't have to be perfect, but the closer you are means the better the burner will line up when you are actually firing it. So tighten that down. We are not tightening the square yet, so don't tighten that. Now to our jack shaft, we need another arm. So let's put that arm on. So what's important with linkage is you want straight lines. So you want direct power transfer from here to here. So if we were to set it up like this, we don't have a very straight line. In this case, we want to get it as close as possible. So a direct power transfer would be a straight line. So we would want this arm, which is fixed. This motor's fixed. This we can move on the jack shaft. So we're going to want it directly above this arm. So it's directly above, doesn't have to be perfect. And Cleaver Brooks also calls for this arm to be set at 45 degrees because it doesn't actually really matter right now where this is set up on the jack shaft. So let's tighten it down. Oh, didn't stay. That's because we don't have this set. So jack shaft is just going to move. So the arm position on the jack shaft doesn't matter. But now let's move this cam in. Let's make sure it's in the middle of the roller. And you're going to want to now put that on the arm, set it at 45, and move the cam all the way down so that you are between the first and second screw, which is right around there. Cam is set. I'm going to roll this down. Tighten both screws. And once you tighten these screws, you should never have to undo them. If you need to make any changes, you're going to make changes on the arms. So the spring is pushing up, so it naturally wants to roll the cam so the spring has the least pressure. So let's double check that. You can see we're right there. Let's connect the motor to the jack shaft connection. So in this case, we have these little bushings here that are going to go inside this ball housing. It's going to take up the room between the bolt. So if you don't have that, you're going to have all this slop, and that's going to be a no-no for linkage. So you're going to want that bushing. The bushing also spaces out from the end. So if you don't have that bushing, you're not going to be able to move this as far. So it spaces it and takes up all the play so that now that this can move properly. So we're going to want to put it on the slower end. So I always like to put them starting all the way out, and we'll see how that plays out. You're going to want to adjust this length too if you need to. These are both set at 45 degrees. So just adjust the length to wherever you need. Just making sure nothing moved. We're here. Let's check this. 42. So we moved a little bit. Need to loosen this. Turn it in. 46. And 44. Good enough. Let's make sure those are tight. Cam is still in the proper position. Now we can make sure our travel is correct. In this case, this cam has 12 screws. We're in between the first and the second one on the roller. We're going to want to take this off the square. And since the motor moves 90 degrees and the square has 4 sides, if we just index the square on this end right here, just once. That's going to represent the motor moving 90 degrees. So you can see we are on the 12th screw. So we know that our cam is correctly set and that these two angles are correctly set. So there's a reason why Cleaver Brooks spec'd that 45 and 45. If you get it super close, your cam will have the correct travel. If you have these way off, I mean, you could figure it out and set them somewhere else, but in this case, we have a one-to-one relationship. So this top is going to move at the same speed as the bottom because they're the same angle. Always remember to take the square off, and you want to push it back down into low fire. And now we can come over to our air. So for our air, it's going to be 45 degrees as well, unless you have a high turn down burner, and then it's going to be 47.5 degrees. So with the air, we also want to look at the alignment. So this one is a little different than this. This is moving in the same direction as this, whereas this moves up and down here, and this is moving in an arc the other way. So we need to set this arm, and we're going to be connecting on this side. So this side of this arm needs to be the center of this arc. So if we're all the way over here and we were to connect it like this, we wouldn't have a great power transfer. It would work, but we'd be moving at the ends of these ball ends. We want the closest and most direct power transfer. So just to illustrate it. But so we're connected on the right side, and see how that will hang down directly. So you want to be in the center, and now your air is probably going to be out towards one of these two ends, which is going to be a slower air response. Right here would be the center of that arc. So your air is probably going to start around here, and it's going to end around here. When this connects up, it's going to move in and then over, but it's in the center. So in and then over, in and over. If we have it all the way over here, it's going to make super awkward over here. You can see it's binding up over here. Even if we have it this way, it's now trying to pull it this way and up. So you can see it binds here. So we're going to connect this at 45 degrees. Boom. That's why they pay me the big bucks. And once again, if you have a high turn down burner, it'll be 47.5 degrees below horizontal. 45, 45, 45. And then this is the only one that doesn't line up. I've asked people about this and not gotten a great response. Cleaver says this needs to be 60 degrees below horizontal. So 60 degrees below horizontal ends up being right there, which is fine. But then the arm that actually connects it is never long enough to where you need to have it. So no matter what I did when I was setting up these burners, this linkage rod was never long enough, and you would never get the right travel if you would make it at 60 degrees. So what I do is I set it to be slow. So on the receiver or driven end, moving away from the axis of rotation makes it slower. And then on the driver, moving towards the axis of rotation makes it slower. So for the integral burner, this is very important. A lot of them are older and have a lot of wear and tear on them. So you want to make sure that the air damper moves correctly. So the air damper should flop back and forth almost as easy as this does. If you have to really struggle to move it and you can't move it with your finger, the inside bushing, there's like a bronze bushing, it needs to be cleaned and has too much friction. And you need to put some dry lube on there. Don't put grease or anything that will cause too much friction. It should move like that. That'll require you pulling the whole burner out and servicing it. But it's highly recommended. Don't try to skip this step, because if you do, now with the power transfer of this motor, it's going to have to go through all this, and you lose a lot of efficiency when you do that. So while you may be able to like move it with your hand and like, oh, I can move it, it should be able to move, this motor is going to struggle. And if You can't move this easily. You're going to be putting tension on all these connection points, and it'll eventually slip, and then you'll set the boiler and you'll have an unhappy customer. And then in this case, you won't be able to do this on a real boiler, but in this case, on this trainer, I can zero out where we're starting. On a real boiler, the air damper needs to be 1/2 to 3/4 of an inch open, and that will allow for enough air on a pilot and also enough air for stable light off. That's for another video, and we'll do that with an actual burner. Now we're all set up. Recap: 45-45 travels between the first 2 screws all the way up to the 12th. 45, 47.5 if you have a high turn down burner. And then this I set up just as far as you can go down. Just remember that the farther this is pointed down, the slower your air response will be. So if it started about horizontal and then went up, your air response would be super fast because it's moving in the up direction, which is going to spin this air damper faster than it is if it was pointed straight down. It's going to start moving over, and it's going to move left direction, which is going to be slower. So we'll take the square off. And we're good. So we're good on the gas. And on a real damper, you're going to have a stop. So you want to make sure that you're not against the stop. So in this case, we are moving 62 degrees. A real damper is going to have only about 45 degrees of travel, I believe. So let's try to emulate that. So I moved this in a little bit more. Let's move it back to low fire. So we are good on low fire, but now we're not at 0 again because I moved this. So with every time we move this, we have to change the length of this. This is the maximum length that I have. And so I moved the driver in, so we're gonna have less travel. But just make sure that when you're doing this, nothing's binding, and you should have a little bit of play. You don't want this damper. You should be able to take this off on a real boiler. You should be able to take this off and move it a little bit more. You don't want it pushing against the end. Let's make sure everything is tight. So you want to make sure everything is tight before light off. So we're good there. Good there. Good there. Don't forget to change it back down. And then we're going to tighten this up. These screws don't have to be crazy because it's already on a square. So they're not holding it from turning. It's only holding it on the square. No need to get crazy. Also, you don't have to get crazy on your set screws yet. We just want to make sure that the boiler is going to run correctly before we start really clamping these things down. So now we're going to start the boiler. And since we've already gone through and made sure that the linkage moves, we're going to know that the boiler during purge is going to have good travel. This is probably going to be your low fire position. And in this case, we're only at 29 degrees. That's about what I would get on a real boiler. Now we got to go to our gas valve. So our gas valve, we want to make sure that this is set 50%. So let's move this. So we want to be able to move the length of this. And if it's all the way set one way like it was, we're not going to be able to move it. So you can do that with this. You can also do that with this arm right here. That is set there. And then this arm, you're going to want it down like this. This is the Siemens one. You also the original Cleavers have the Honeywell valve. So this is the valve that you're going to see on newer Cleavers or anything that the gas valve has been replaced. This is all custom. This is how they look from the factory. And this is the Honeywell that originally came on the Cleavers and is out there. It's missing the screws. If you had a screw, this would stretch. This is also over travel, and the springs are spring-loaded ball bearings in here. A little more clever than this style, but this style works as well. This is what a butterfly valve looks like, in case you didn't know. So old Cleavers, this is for Honeywell, 2.5 inch. They don't make these anymore. So you're going to need to get a Siemens one. This arm needs to be set down like that. Don't have it horizontal. Don't have it straight down. Always like this. You can index it here with these 2 screws, but you're going to set that and forget it. Your light off position is going to depend on your gas pressure. Right now this is at 10 degrees. It may be a little bit more than that, but it's always better to err on the case of caution than lighting off with more gas. So now we're going to turn it on. We already know that this is good because we've tested it. So this mod motor is going to move 90 degrees. So we're in purge. So the fan is running. We're running up to high fire. We're going to be making the purge switch. Purge switch is the blue cam inside of here once we get there. And that purge switch is what lets the flame safeguard know that our linkage, or at least the motor, is in the high fire purge position. So now this would be the high fire setting. So maximum air, maximum fuel. Now the boiler is going to run for probably 30 seconds or a minute, depending on how long your purge time is. So you'll notice this is all correct. So we've already checked that and we know that nothing binds. It's very important. So now it's going to automatically, after the purge time, it's going to go the other way. So now we're coming down. Fan is still running. We're in purge still. Fan is still running. Gas is closing. Air is closing. And what this red cam makes, which is your low fire switch, is when the flame safeguard is going to go to pilot or ignition of pilot. We want to set that so that this is still moving. So right now it's going to come down. See how that makes? And that just barely moves a little bit past it. You want this arm to keep moving past it. If you put it where it's just right against it so that the low fire switch makes exactly when this stops, you can have it where it barely doesn't make the switch, and then you'll get a call back. If you need to adjust it, you won't have a clear top. You'll have an aluminum top. So you take a 1/8 inch screwdriver in there and you adjust. So let me just adjust it right now. So I just moved it. Let's move this out again. So we're going to come down. This is moving. Oh, low fire switch made. We're too far into purge still, and your pilot's going to blow out and you're going to have an unstable ignition. So I've adjusted it so now that the cam is in the wrong spot. So even though it is lighting off, this was moving too much. So let's adjust this. Easy way to do this, to adjust it. Now you won't have a red light to know when it makes and doesn't make, but you can play with the switch. You'll figure it out. That'll be another video. So let's move it up a little bit. We're going to set it, in this case, to make. I'm happy with that. So let's go over this again. So coming out of high fire purge or high fan purge, we're driving down. We're going to drive down to the ignition position. Air is closing, gas is closing. We just made low fire switch, and this is still moving, but only a little bit. So that by the time the pilot lights, this should basically be in the 0 or low fire position. Now our pilot lights, we prove pilot, then our main lights, we prove main, and now it can modulate. If you have a manual potentiometer like I do here, you can keep it on low fire and it's just going to sit here. You're going to want to adjust combustion, but you're going to want to get it so that it lights off, but it doesn't have to be perfect. Things we're going to want to look for is just that our O2 is around 7%, high turn down burners 9 to 10%, and forgot to mention, but your cam should follow the profile of the curve here. So these screws should be pretty flat. There should be no peaks and valleys out of it. So all of your adjustment is going to be made, 95% of your adjustment is going to be made in these angles, and the last 5% is going to be made in the cam. And the cam is going to allow you to dial in your combustion. The angles here and how you set these lengths are going to be how you're actually going to make the large changes. So if you're making large changes, when you light off, if you're at 1% O2, don't make changes in your cam. You need to make changes in the length of your rod here to close the gas more. You're not going to want to touch the air. The air is going to be about 3/4 open. You don't want to open it too much, otherwise your pilot will be unstable. So if you set your air in the proper spot for light off, you should be able to match your gas. If you do have a flow meter, you can match it with your flow meter and then match the air, but highly unlikely you have a flow meter with a manual linkage burner. So then you're going to run it up to high fire slowly, making sure that you have good combustion. So when you can see the bottom of this, so a rising stem is more input. So when this is turned all the way up and you can see the bottom here, that is a higher firing rate. And when it's turned up all the way, that is high fire. So you can see our gas is opening. Now our butterfly valve doesn't stroke 0 to 90 degrees, and the butterfly valve won't move as much as the air damper. So we're at high fire, and you're going to want your butterfly valve 60 to 70% open or degrees open, whatever it is, whatever it's at, and then increase your manifold pressure with your regulator so that you're now running at, say, 3 to 4% O2. You're going to slowly come down and adjust each one of these, and you're going to adjust it to what it should be. You shouldn't be making huge adjustments, but you should just slowly come down from 3 or 4% and rise to 7 to 10% O2 depending on what you have for a burner.